And good morning, good afternoon, good evening, everybody. How's everyone doing today? Welcome on into the Dragon's Den. Uh, my name is Digital Dragon. I'm a 3D print variety streamer here on Twitch. I see Monlight and Chewy are here already. Chewy, I hope you're able to get some rest. And Monlight, I hope you're doing well. And once again, sorry, I completely forgot about putting any heat set inserts in your parts for the Rook 2020. Just with the two builds going on and everything else, just kind of like gone. Yeah, good morning, Shadell. Good morning. Oh, you happen to have COVID, Chewy? I'm doing pretty good. I do have a hard stop today at 2 p.m., so I do have a couple of alarms set up so that I do a hard stop right at 2 because I need to head off and drive into Raleigh, which would be a little bit of a drive. So, good morning, Frank and B. How are you doing today? Long time no see. We got our morning coffee going. So today on the stream, we're switching gears again. We've been working on the Annex Engineering K3 during the week. Now we're back to Saturday, and we're back to Chewy's 2.4 build. And we're going to take a little bit of step back from where we were at because we made some design decisions during the last stream last weekend, and we decided we're not going to use the EBB 36. We are going to use an SB 2209 for the CAN bus board. So I had to reprint a couple of parts for that, and we are going to put a CNC tap on this versus a printed tap, simply because I was planning on taking the printed tap parts off of Dragon right here, but I haven't had a chance to take that one down and do some maintenance on it. So quite possibly after we get the Chewy build going, Dragon right here may come over to the bench. We'll peel the panels off, and we're going to take the gantry out, and we're going to rebuild the gantry using the CNC the Chaotic Labs full carbon fiber kit. That'll be the carbon fiber tubes for the gantry, the carbon fiber tube for the x-axis. So we'll swap all that out, AV motor mounts, the whole 9 yards. So that will get a lot lighter. We'll switch that from a printed tap to a CNC tap V2. And while we have it on the bench, we'll swap out, we'll swap out the Mini 128/64 display for a touchscreen like we have over on the Kyber Dragon, the LDO Kyber Dragon. So yeah, I got a few things going on there. Right now, all right, something's annoying me with that one. I'll have to look at it. The Trident is getting some work out as a test bed at the moment. So that's why that one was going. But yeah. And I realized the Trident is a little bit more difficult to do some changes on, just because your tool head is at a specific height towards the top of the machine. So there's certain parts that are kind of a pain in the butt to get at. If you say got a CAN bus cable there and you've got a locking mechanism for the CAN bus cable so it doesn't come out. Yeah, trying to get back there to get some screws and it's a little bit of fun, but it's all good. You're going to get the CHC Pro. Okay, Mod Light, sounds great. Yeah, definitely get out in the Voron, the Discord forums for Rule 17 and see what everybody else is working on as far as the hot ends and stuff. And that way you definitely get one that'll work with either the rookery or whatever you decide to put on it. Now, I'm trying to think, my 2020, I'm not running the rookery. I'm running, what does he call it? The Sentinel toolhead. And then I believe Zombie also has got the a dragon burner on his, because there is a dragon burner mount that Gulsifer updated. So anyhow, we're gonna start. We're gonna bring this bad boy back up here. Make sure I don't knock my coffee over. And we're gonna work on mounting our belts. God, look at it. Work. I will have to say this is probably one of the smoothest ones that I got set up right now. So, Joey, we did good on this one. We did good on this one. So once again, we are going to work with the Chaotic Labs CNC tap. Now I have put in a couple of these without doing any type of pre-maintenance, just assuming there was enough lubrication in here, because really, like, that's your travel movement. I really don't think there's a need to take this apart and put a butt ton of grease in there when that's our movement. You tell me, Chewy. I mean, if you want, I will take the front off. I will pull the carriage off and add some EP2 in there. But that's the totality of your travel movement. But I like this. This has got the sensor built in. It uses a larger magnet rather than using the two small magnets. It does use a was it like a 6x2 or 6x3 strip magnet in there, and it does have the provision to mount the end stop via a little metal bracket as well. So we will use this to get things set up. Let me, I think I want to put the end stop bracket on first before we do anything else. Let me find set end stop bracket. But then we will go ahead and get the belts cut to size and run. And then once we have that, we'll go back over and finish working on the tool head. And once again, we've made some design changes on the tool head, changing up what board we're going to use. So we may have to backtrack just a tad bit on that. Okay. And there's your little end stop bracket. So we'll go ahead and get this mounted. It'll mount just like that. We'll be able to add our end stop in, and then we'll be able to add the end stop to the tool head, and the Y will get mounted back here. And because we're going metal into metal, I am going to put a little bit of thread locker on these just to make sure that they don't go anywhere. Should be finishing up wiring and flashing your 2.4 today. That's awesome, Frankenbee. It truly is awesome when you get to that stage of a build and you're like, ah, the end. We are at the end. But then you also get to go into all of the tuning and stuff like that. So you want the Sentinel, but you can't find one. It's just different printed parts. I believe it was a mod, possibly just in the 2020. So if you look at the 2020 files on printables, you should be able to find. Like I said, I think it was a mod. I'm trying to remember who did it. Was it Turtle? Can't remember who did it. Who did that mod? All right, I think I talked myself into putting a little bit of EP2 in there. So let me grab one of my paper towels here. Because this is put on with these little, I believe they're 2.5 by 6 flathead cap screws. Tiny little boogers. Don't want to lose those. And once again, they say this isn't necessary, but I think they just say that for the vast majority of people so that they don't jack their rail up. Like, why is that not coming off? It's because the other screws are already in it as well. Why it's not in the package. So you've got the 4 mounting screws that mount it to the to your gantry rail, and they're back there as well. You need to pull those off. At least pop the top 2 off, which have little O-rings on them, which are really nice to also get stuff going everywhere. So they changed the design up. They used to have a 6x3 magnet right here at the top, but they've changed the design to these smaller magnets down here. And that's interesting because they are put in and they have an angle to them. That is pretty interesting. You can see some of the shipping oil on there. So we'll wipe some of that off. And we'll open up we'll take the carriage off. And we'll go ahead and get a little bit of EP2 grease on this high wind rail. I'm not going to take it all the way off. Just do the standard. I'm not even going to glove up for this lube job. Hey, Zombie, what's going on? The Zombie, my light's doing the Rook 2020. Dark blue. For primary PLA parts, and then the rookery and the bed mount are done in orange ABS. And once again, I'm not going to glove up. I'm just going to go ahead and push this into the balls with my finger. And then slowly put this back on to not lose any balls. It was working a lot nicer. I'm going to add just a little bit more. And once again, this is a genuine high wind rail that they put on these. And it's what is this? MGN 7 high wind rail. So very, very tiny balls on these. You do not want to lose these because they will go everywhere. Hence why I'm doing this over a paper towel. So between sticky grease and a paper towel, I am hoping I've got enough juju left to not lose a ball. Hey, no balls lost. Work that grease in a little bit. Like I said, there's really not a whole heck of a lot of movement here, so that's where I was kind of like, I'm not sure if it's really, really, truly necessary. But just to make sure you have the smoothest movement, it is kind of worth taking those couple of screws out just to do this. Now, Zombie, on the tap changer, you're only going to need one of these, right? One tap? Or do you need one on each tool head. So I know you're going to have 6 tool heads, 6 tool heads, 6 extruders, the whole 9 yards. But you only need 1 actual tap, right? Yeah, that's there. We'll go ahead and get these back in here. And I didn't need to take these out. It was more of the the rubber goes on the back side, not the front side of those. It was more a case of just the magnets being that good and that tight. Oh, wow. So you have to have 6 tap modules. Oof. And are you using like the CNC tap, or are you going to use printed tap on those? I was about to ask how that works, but no, that makes sense because the tap's going to tie into the tool head board, or at least the sensor itself will. Okay, so this should just sit right on top. Magnet should align just like that. Put in our tiny flathead cap screws. Good morning, shenanigans. How are you doing? We are sitting here playing with extremely tiny screws this morning. Don't know what the hell I was thinking with not having much coffee in me yet, but apparently we thought it wise to take our CNC tap apart and add a little bit of EP2 grease to it. Oh yeah, that's moving a lot nicer. Good job. Glad we decided to do that. Okay, so a couple of mounting screws. Those mounting screws go in. Which one? Where do they go? They go here. So these are the bolts that'll go in that your hot end piece will clip under. And then we'll add a couple of button head cap screws right here at the bottom. And that's where it'll have the 2 tangs that'll clip in. and then rest on the bottom two. And then your two long screws will go through the bottom one, and then the top two is where your CW2 will mount. So we'll get that going. We'll get that started. We can get this out of the way now. We'll put these two away. Then we'll bring the printer back up here, and we can start working on some belts. Yeah, it's funny how that goes, how it's like, okay, I've got project A, but before I'm even really started on project A, I've got like 5 other projects to go. That's why I said I still have a Micron, the V01 to V02 upgrade, the Trident 350, which will be bigger than this one, and a couple of other bench projects going on. I'm like, this is got too much going on. So normally we will take one of these, we'll route it, and then we'll get a good sense. I don't think they give you a estimated belt length, right? They just tell you, yeah, run one belt, get the required length, pull it back out, cut everything, and then go for it. Awesome. So I'm going to get me a length of belt that I can work with. And this one's going to come around here. Great part is that means I get to play around with the front idlers a couple of 3 times. All right, Zombie, so you've built a few of these now. Do you normally just kind of estimate your belt length and then go with it? Or do you actually run it one fully and then plan ahead? Because I know I'm about to just do some estimating here. Through here. Yeah, we're just going to do some estimating and then measure off the 2 belts so that they're the same size. And then we'll come around and belt it. because I know I'm going to play. I have fun playing with these idlers, and I'm just going to get annoyed. So standard trick: line the belt that you just quote unquote pre-cut. One tooth, well, the remaining belt goes into the first gap, so that way, as you line these up and you pull them through, the first gap that you see underneath would be where you're going to cut at. This is an easy way to make sure that your belts are the same number of teeth, which will make it easier when you do your initial install, and then tensioning becomes a lot easier down the road as well. Okay, not even going to worry about that. So there we go. And we're going to be working on which one first? The A belt, which will go through this drive motor. And you'll see me, I'll tend to start like at the back, just because for me it seems to be a little bit easier to start back here with, if you start at the motors and you always get your teeth going at the motors, then life becomes a lot easier. Yeah, you do the run once and then pull through, yeah. Yeah, the last thing you want to do is be like halfway through running your belt and realize when you get to your motor that, crap, I ran it the wrong way and I've got the flat at the part where it should be running up against the motor. Turns into a bad day. This side comes up, goes past, comes down to the front idler. Then probably the easiest time I had doing, going around the idlers was the salad fork when we did the pin mod. Definitely the most easiest time I had running belt through idlers, because I was able to build it you know, you were able to run the belt as you built the idler. And these belts feel super, super stiff. Good morning, Creatix Britt. How are you doing today? Well, explain to you belt here. That night, I hate how I have to always fight because it'll fall down into the channel, and it's not supposed to be in the channel. It's supposed to be basically right up against the flat edge. So belt one up here, belt two down there, and I invariably get some part of the belt in the channel, and it drives me insane. So we have one edge, and what we're going to do now is we're going to undo our belt clamp here. We'll run the left edge in here, and we'll get the other belt started as well. So the belt's going to go in from the back and flip around underneath that belt clamp. All right. There we go. And it's just like normal. It just wraps right around, comes in from the back, goes around. You'll figure out a number of teeth. do the other belt, clamp it down, and that's where you get to start from. Ugh. Hey, Rodney Mac, how's it going? So for this other belt, I always find it easier to kind of come into the pulleys from a specific direction. So I'm going to go ahead and try and run through this pulley. That one seemed a lot easier. And through the pulley, around the lower tooth idler. I'll bring this in here as well so that we can get the same number of teeth rolled over, and we can put our clamp on. Now I'll probably cut the belt to length after the fact. Or I mean, cut the belt to length. First I'm going to cut the belt to length. I'm going to cut the tails on both sides of the belt to length after the fact. Okay, so that's what we're trying to do right there, is get our belts with the same amount exposed. We'll cut these shorter after the fact once we get our belt run. Like I said, we're going to have plenty of belt. And then for giggles, I'm going to go ahead and try and just mount this on the one side to keep it from moving around on us as we finish routing our belts. Once again, this is simply to hold this in place to keep it from moving. And we're going to add a couple of our stops, because as we start pulling on these belts, it's going to want to move the tool head. So we're going to add a couple of stops in here just to kind of bracket the tool head and keep it from moving around on us. Of course, let's go. Got the left side in, so we'll go there. Make sure that everything's lined up on our pulleys. So I put it on one side, put the stopper on the other side as well. And that will kind of lock in my gantry. and make it a little bit easier for me to route the belt now. Now, on this side, as we're bringing our belt through, we're going to be going through our motor. We're going to bring all this excess through and tighten this up. Now we're going to be going through our motor. And back around our lower pulley. The routing isn't hard. It does take a little bit though to get, to make sure you're getting around the pulleys in the right spot. So just take your time. And then once again, before you start really tightening and pulling tight on your belts, turn this around. You need to make sure that your belts are lined up in these pulleys. See, that one was up some, so it would have been on a ridge. Make sure they're on the teeth on your drive gears and not riding up, so that everything's lined up in your idlers and your pulleys. And then you'd be able to come in and do the front latching and pulling things tight. So what I'll do now is remove this clamp. We'll be ready to install that in just a second. I'm going to take this back off so I can route my belts through the back. And then we'll be able to tighten everything up. Once again, make sure you get the right, make sure your bottom to the bottom, your top to the top. And see, I just screwed that one up because that was the top belt, not the bottom belt. And I estimated obviously a good amount of extra just to make sure I didn't cut my belts too loose or too short. And now that we've got that, we'll line our piece up with the carriage, screw it back down. And what I'm going to do is screw down both of the left sides, not fully, but close enough. And what that will let me do now is apply some tension on the right-hand side here. I'm going to line up my belts and just cut them quite a bit shorter. Make it easier to line my teeth up. Same type of thing. If I lined them up before, I'm going to cut one short, and then I'm going to do the same type of technique to cut the other one short, because I can't guarantee that the number of teeth exposed is the same on each side right now. But I do know that my belt lengths were the same. So if I go through and do the same technique, now I've trimmed off the same amount of belt. And like I said, I got plenty of excess length there. That's like I could toss somebody some rook belt. Okay. So now, since I'm the same on the left, I can try and pull these and get them the same on the right. And I'm just snugging these by hand. I don't have to have this fully tight now, because once again, that's what my front idlers are for, will be to tighten this up fully into place. Just go ahead and get my belt tensioner started. Okay, once again, I'm going to walk around and look at all of my idlers to make sure my belts are good and well within the, sitting in the idlers and not riding on any of the bearing edges or the flanges. Because if it's riding on one of the bearing flanges, you can think, okay, my belts are tight. And as soon as it starts moving and it falls off of the bearing flange into the bearing, now you're going to have one belt that's looser than the other. And you'll start seeing some artifacting. Pop my little rubber grommets out here. Pretty tight, so I can probably get another one or two teeth pulled through. And I'm trying to hold this tight and my clamp turns on me. There we go. My belt distances are slightly off, and I've got a little bit of play. So this is fully back. There's a little tad of play here, and that should be able to be resolved just by doing a little bit of tensioning. Yeah, I mean, we're talking like a very, very minor amount, so we'll be able to get that tensioned up when we tension our belts, and we'll get rid of that tiny, tiny, and I say tiny bit of racking. Oh, I guess it'd also help if we go ahead and do all 4 screws here. All right, so our belts are run and our CNC tap has now been installed. Exactly, that's what we were just checking, is to make sure that our belts, and I'll bring you guys in a little bit closer here. We want to make sure that our belts are riding in the bearing and not sitting on top of a flange. If it's sitting on top of a flange, your belts won't line up right and you'll think you'll have them tight and it won't be. And as soon as that belt gets a little slack and actually drops down into the flange, now you've got a floppy belt and your belt tensions are off and you can rack your frame. So all of our belts are riding true. And then this is what I was saying about, I pushed it all the way back. There's no play over here. And there's a tiny, tiny, here, let me get you guys this way. So there's a tiny, tiny bit of spring right here. Kind of hard to pick it up on the screen, but it's ever so tiny. And we can fix that once we tension our belts. It'll get fixed once we tension them. So we've got our gantry built. We got our belts run. We have our X carriage on there in the form of a CNC tap. We definitely wanted to make sure that our tensioners were all the way loose, which they are. We didn't do that part because, well, we used a different method, running the belt through the pass. Oh, I'm sorry, I'm sitting here on the wrong window. I'm thinking I'm showing you guys the manual the whole time. This will be using the traditional mount with the inductive probe sensor. Making sure that your belts are routed appropriately and everything. Mount your inductive probe, which we're not going to be using. And then it says go into your tool head. Our tool head, we were doing the Stealthburner. So we got our initial Stealthburner tool head built. However, we are going to go back and modify this slightly. We're going to take these mounts off because we're going to mount our SP2209 board on there. And words sometimes. I'm just going to start by pulling this in 3x6 button head. Now I did print a different door because there's a different door, or at least a different door available for the SP2209. I just want to kind of compare this door real fast. And yeah, we're going to swap the door. It might be hard to figure out, but it's right here at this point and this point where there's a slight difference in those two doors. This spot right here where it goes straight all the way back, where this has this additional curved piece. So we need to swap the door out. And to do that, we've got to open the clamp so that we can get to the screw to pull our door off. Oh yeah. Yeah, that Trident 350 I'm going to do is going to take up a whole lot of space. Hey Geiger Counter, how are you doing? We are working on a Voron 2.4 300 size. So this is a build for one of our stream subscribers named Chewy. And he's been working a lot of overtime and stuff, and he just asked me if I would be willing to build the printer for him, and I told him yeah, as long as I could build it on stream, and he was okay with that. So of course, if I was not building it on stream, I probably could have had it built by now, but good content for the stream. Trying to clean up the printed edges some. I printed this door with a brim because I have had issues with these sticking. It's probably to do more with my speeds than the build plate and adhesion and first layer itself. It's just the fact that I tend to run fast, and with so little contact surface, it doesn't take much of a of a hit to knock a piece off. But because we're going to have wires in this area, I just want to address any potential sharp points. Okay. And while I've got that door off, I'm going to go ahead and undo the standoffs, and we'll replace these screws with the proper screws that go in it rather than trying to do these standoffs. How are you doing today, Rodney Matt? Um, I want to say this is a M3x8. Give me 1 second here so we can swap these screws back out. M3x8. And this one is the one that sets the tension on the motor, so I need to make sure I'm holding that motor in place when I pull this screw out. That's M3x30. Watching build, praying, and taking it easy. That sounds like a great weekend right there, Rodney. That's there, that's there. Still need to have this open to put the new door back on. Threading into plastic, that's why it's just a tad bit more difficult. And once again, you want it so that the screw head is just beneath the printed part so it doesn't interfere with your idler closing mechanism. But you don't want it so tight that the door itself can't hinge, right? That's good. We'll was mine. This is the what we use here. 3x12. Do we have any of those in here? Toss that back over there. We will swap this little button head screw over. Okay, so that piece is there. Now I know from history, and the fact that I just did this last night on my Trident, the SB2209 board that we're going to install. I put it, oh, put it up here. So the SB2209 board, I love it and I hate it. I love it because it's a feature-rich board. I hate it because it uses these tiny little flipping pins. And trying to, I mean, these are like a 1 mil pitch, and they're very, very, very tiny. Now, what Big Tree Tech has done in their infinite wisdom, and after getting a lot of people yelling at them, is they started providing these little ribbon cables. And at first you go, okay, well, who cares about ribbon cables with a little bit of wire sticking out? Well, then you realize that these ends have crimps on them. So they provide you plenty of pre-crimped pins if you need to use them. But that means you're then soldering or doing something else. The other nice thing that they did, and this is fairly relatively new, is they started providing a pre-crimped on these little tiny 2-pin thermistors. And that's critical because your 2-pin thermistor is this first connector right here. And if I line this up with the holes going where they need to match, where's that 2-pin thermistor? Right behind this piece. So you actually have to get your thermistor clipped in first, then move your board into place with the backer, the little standoff backer piece there to install the board. So it's kind of a bit fiddly and a pain in the butt, but at least they provide you some of the goodness that you'll need. So we'll swap your thermistor out with this one, unless that's like a PT1000 thermistor, Chewy, which I didn't think it was. So yeah, after a lot of complaints and feedback, they are starting to provide better support and tooling in these. They do give you all the crimp and stuff that you'll need, but it's still just a pain in the butt. And of course, I'm going to have to take this apart to swap your thermistor out. Yay! And there's also a different, because this is going to be CAN bus and we'll be using the integrated or the supplied CAN bus cable, there's a different mount, I'll say, for the back of the extruder, of the cable mount. We pop this out, we'll go ahead and replace the extruder here. And this screw that I'm grabbing right now and pulling out It is simply there as a blocker. There's one on each side to prevent the heating element and the thermistor from just popping out on their own. Yeah, that looks like just a standard thermistor, doesn't it, Chewy? Well, your Rapido's PT1000? Yep, I finally got one of those myself, and I was fretting like, I've never done a PT1000. Oh my God, what do I do? What do I do? Yeah, it was an anticlimactic thing. It's changed the sensor type to PT1000, and on the board here, depending on which setting you use, there's this little dip switch pad right here. You take the little plastic film off and you set the dip switch, whether you're using a PT100 or PT1000 2-pin or 4-pin. That's it. Really easy. Hey, good morning, Liz. How are you doing? How are you doing? I hope you are doing well. So anyhow, what was I doing? Oh, we were going to put in their thermistor that they provided, which should have a plenty enough cable to get in there. Be decent fit. There's enough thermal compound still in there that we should be good. Nice and captured in there. So now we will wires route this way. We're going this way. And I will cut and terminate this to length once we get in there and I figure out about how much length I need. And we're also going to add in the appropriate screws at the top here as well. Not that that hot end's going to go anywhere, but calls for screws, so we'll put screws in it. Because I did order screws and I got screws in, so. And honestly, Chewy, what I'm going to do is figure out about where that is. I'm going to go a little bit further because I know how I need to route that cable. And I'm just going to cut these off. I'm done fighting with these. Back over there. This is the part we don't need anymore. Um, 2.5, and I believe these are going to be like 2.5 10s, maybe 8s. It does work, but apparently it's going to work. Yeah, it's a good thing I went and got these M2.5 screws, Chewy, because I just mounted another hot end and wound up that the screws that came with it didn't work in the mount. So I needed to dig into these myself. Okay, so we've got our hot end kind of pre-done. We'll worry about crimping the end here a little bit later. So this is prepped. This is almost fully prepped. What we're going to need to do is do our cable support bracket piece. Like I said, this is a two-piece contraption. So I will need to put a heat set insert in this side. Let me get that up here and get that going. Correct. It's 11:30, so we've got 2.5 hours. I've got a hard stop at 2 o'clock today, folks. Thank you for keeping an eye on the time mod light. And so what you've got here is this piece, and I obviously need to get the swerf, or not the swerf, but get the rest of the thingamabobber out of here. This piece here, what it does is it holds the USB socket in. And I cut this bottom piece out just to make life easier if you ever have to do maintenance, because it makes it easier to move that board around. But the bottom on this piece is really designed to sit underneath the USB-C socket on the SP2209. So this is going to come around and you've got the USB-C socket and it's going to sit right in there like that. And so it's got the bottom piece there to provide support underneath the socket. But once again, you're going to need to be able to move this around a little bit. So having the ability to rotate that without having a bottom in there could be beneficial. So let's see. Book 2020 parts, nice, too funny project when you're starting. You have a Christmas party today, Liz. Awesome. Awesome. Are you going to take a bunch of prints with you? I don't know, Pez. What did one wall say to the other? No, we will not be printing today, Zombie. Hey, Zombie, did you get your special package from Fetus? Meet you at the corner. Yep, there you go. Aw. Your V0 is printing? Awesome. Awesome. That's great. That's good to hear. Yeah, I got mine. yesterday, so I started playing with that yesterday. I was a tad bit excited when that package showed up. Okay, so we got that heat set in there. We let it cool down a little bit. And the way this works is the top one comes in from the back side end, and then the other one comes in from the front side end. So we're going to put this in place, and it calls for what? Did I miss it? Oh, there we go. M3 by 20 from the back. You are taking lots of prints. Good. I tell you what, there was a part of me that was really seriously looking at an A1 with the A1 with the holy crap. Yeah, this is definitely a different print with a different length. So M3 by 20 is not going to be a good one. 12. Well, might do. 10's probably going to be a better one though. Oh, this will do. No, it won't because this doesn't go all the way through. So hopefully that went in the right one. Not sure if an 8 will make it all the way through. If it does, great. If not, there's no threads there. So what I'm trying to do is figure out the right screw to use here because this is a different part. And using the part that they call out, your screw can be that long because of the way the part is. This is a completely different part. So we're having to adjust on the fly. And the one coming in from the front is going to be an 8 as well. So once again, the our USB-C is going to slide in there. It's going to basically just slot in like so. And then we'll have another piece, and I forgot to put the other hot heat set in there, but this is going to come right in there. So it's got a little bit of a cutout for the USB-C, but this will screw on there, and that's going to hold the CAN bus cable and provide support for the CAN bus cable. And it gives you an anchor point because these two holes right here, you'll take some spring steel wire and loop it around through there, and you will use this as a cable guide. I will need to add another heat set in there. I'll get that in there a little bit later. We don't want to have this permanently mounted just yet. We'll mount the board once we kind of get things in place on the printer because we'll need to move some things around. Standoff that we'll use for the board, there's that. And that. Yep, and the rest of these are other parts. V2.5. So we've got our CW2 pretty well done. We've got our tool cartridge, we'll add our DuPont connector shortly. We've got our SB2209 board here with our standoff spacer that we'll use. And then we're going to start working on our fan shroud. So that is the other piece that we need to do is we need to pop in a piece of PTFE tube here, make sure it's fully seated down on the hot end, and then we'll figure out our length and get that cut, and that way that's ready to go. And for these, I know everybody likes the high temp cap tubes. If you're going to use your high temp cap tube, get the 2 millimeter inside diameter if they have it. Do not get their, whatever their super tight tolerance one is. You will have problems. Okay. So make sure that you've got the nicely cut flush end. I know this was nicely cut because it still had the mark on it from where I cut some tube off here last night. And you want to get this put in there, pushed all the way down. And of course, when it's way super tight, do yourself a favor and back your clamping screws off a bit. Or better yet, put your parts together ahead of time and run a 4 millimeter reamer down through there. Yeah, because that's not getting down in there, I don't think. Oh, am I getting down in there? Okay. I'm going to do what I just suggested that we do. So your PTFE tubing is 4 millimeter outside diameter, 2 millimeter inside diameter. We get those loose. We're going to loosen these up again. Possibly. Those are 1.5, not 2. Or, oh, there we go. You'll see what I'm talking about here in just a second. So I'm going to pop that out. I'm going to swap these for 10s. Pop that out, put this back together again. And of course, it's always good to do some build and rebuild and unbuild and rebuild. It happens a lot on machine builds. So we get this lined up and we're trying to put our tube in, and it's just way too tight. We can't get our tube to go in. So what we're going to do is grab our 4mm reamer, because once again, reamers make holes perfectly round and they don't dig in and cut out material that we don't want removed, like a drill would. You don't want your hot end, so no hot end in there. We're just going to take our reamer and we're going to ream that hole out to 4mm. Now our PTFE tube should, theoretically, go in a lot easier. So definitely work the couple of seconds because you want your PTFE tube to fit in there nicely. And not have any issues. And crimped. Didn't think 8s were going to be long enough. And then 10s bottom out. I guess we'll be going back to 8s. What I get. That's what I get. Okay, and just for giggles, to make sure that I'm getting this pushed down in there, I'm just going to take a marker and just run a mark anywhere, somewhere, so I can see whether or not this is actually getting in there or if I compressed it very, very tight. So, yep, and it's going in there. We'll take and we'll shove that all the way down. That is now bottomed out. We'll wipe off my mark. And we need to have 11mm exposed. So I'm going to take my little go build a scale here, which starts right at the bottom tip or the bottom edge. I'm going to hold this right behind my PTFE tubing, and I'm going to mark 11 millimeters on my PTFE tubing. And then we're going to pull it back out, mindful that we don't cover up our mark or wipe our mark off. And then I tend to use just this jig. It was a jig that's designed for the groove mount for like an E3D V6 or anything that uses a groove mount. You put it in there and you cut it off. This is for a Prusa Mark III. But I will get my PTFE tube in there, get it lined up. Get my blade lined up and kind of do a rocking motion over it. You don't want it shoved down because you can still squish it somewhat. You just want to do like a rocking motion and it'll cut right through real easily, especially if you have a sharp blade. And then, as always, deburring tool of some sort. We just want to slightly chamfer both edges. Doesn't need to be anything dramatic, but we just need a slight chamfer because once again, whenever you're trying to remove filament and do a filament swap or anything like that, the filament, as you're doing your retract, is going to have a little bit of a bulbous end. It's going to be a little more than 1.75 millimeters nominal. So that's where you definitely want to make sure that you have a little bit of a chamfer because that will help dig it or help it come out easier. And then just make sure that you don't have any filings down in there if you do. Always keep a tail end piece of filament. Run it through a couple of times, both directions, and that will clean out any potential piece of PTFE that's down in there from doing the chamfering step. And then we want to take that and set it back in there. Make sure it's fully seated. Now this piece is ready to go other than the connector, which we will work on once we do the assembly on the printer. Take our remaining PTFE tube, once again, 2 millimeter inside diameter. Hey Chris, how's it going? How are you doing, Chris 2? And hello Aaron, welcome on in, welcome on in. I feel like we were just building printers last night, weren't we? Or you were, I was watching. Watching, maybe heckling a bit. I love coming on to Aaron's stream, and one of the first things I do is just do the you done messed up, Aaron. And he's always like, what'd I do? What'd I do? Because it's normally right when he's in the process of doing something. Okay, so our CW2 is built. Our hot end section has been built, the tool cartridge. Now we're going to do the actual fan shroud. It wants us to remove some support. So there's these tabs right here that hold the wires down for your LEDs. And we just need to trim off the little bridge pieces that help those print well. You want to do it gently so you don't tear it out, but you do need to get it pretty clean on your cuts, because once again, you're going to be sticking wires through there, and you don't want to have a lot of sharp edges as you're trying to put your wire through there. And that is basically just like a one-layer bridge used to make those tabs there. Okay, so we have these two, and there's another one right up here, same thing. Then one layer bridge there, you're going to remove that so that you can clip the wires that need to come up from the bottom part of the tool head to the top, namely your LED wires, lower fan wires. Okay, so we got those removed. Now we're gonna build our LEDs. Look, Ma, no soldering. It happens, Aaron. It does happen, especially on live stream. I know I was sitting there piddling around last night watching you working on a couple of different things. One of which I can show, one I can't, but we're working on setting up our heater as a test bed so that we can check out if our little PTC chamber heater would be good, or if I need to go up to a higher voltage or what have you. And needless to say, Luke has learned that if you do any wiring late at night, don't test it. Come back the next day and look at the diagram again and trace all the wires again to make sure that it's proper before you plug in power. So I'll be doing that later tonight, probably while I'm watching somebody else stream. So, hey, look, we've got LED lights. They actually did use the proper wiring, I think, so we're good there. So, hey, it's Makerspace. Welcome on in. Welcome on in. You're not a pro like Luke. Hey, you've seen we've done a little bit of rebuilding here and there. So it always says start with the logo LED and then move on from there. I don't. I always start with the bottom, and I'll do the logo once I get the bottoms in place. So the very end of your LED trail is the one that goes, the first one here on the side. And you want your light facing outwards, of course, and it just slides right down into the slot that we have here. Okay. We're just going to take that, slot it, push it down in there until it clicks. Your next one is going to go over on this side. And what I tend to do is get that one pushed in first. Once again, you want all your wire connections to be on this side. So I'll push this in first. Should just push in and clip in. Like so. Now I'll take and force these wires down into the cable pieces here, the cable guides. I just find that it's easier to do it that way than trying to do it any other way. Versus normally easier to do too when you've got fingernails. So the fact that I just cut my fingernails yesterday doesn't help. Talk about not planning properly. And see this little tab here is where you take your excess wires and push it down underneath that tab so they're out of the way, and you don't pinch them on your frame when you're putting everything together. So it just tucks down in there just like that. This one you're going to loop around your tabs here. Just like that, and we'll just run it up this side through the little clip thing there. If you've ever done the stealth burners, I mean, the design that was put into these parts is pretty darn good. I mean, your cable troughs and everything just line up and they work. They've got the little clip areas there that are sturdy so you don't snap them off when you get fat finger like me. And everything just holds into place really nicely. There we go. So very nicely well routed in there, out of the way of the fan that's going to be put in there. Now I can build my little diffuser piece. So our diffuser, so there's a couple of things. It says to print this piece in an opaque material. This particular kit that I bought has resin printed parts for all three. So this is the carrier. This will be the piece. This is your diffuser that the light will come through. And then this would be the piece that they say to make opaque so that it doesn't transmit too much light. All right, Zombie, have a good one. The nice thing with these being resin is they should fit together pretty darn nicely and be a nice snug fit. And it does look like it is going to be a nice snug fit. Now I do want to try and use my my opaque, I'll say outer piece. Just because it'll reduce the amount of light coming through. And here's a key point of note. You've got sheared off edges on each side. You've got almost a 90-degree rounded here. You got another slight sheared edge here. So your diffuser only goes into this piece one way. And it should fit fully in there and line up flat and flush with the front. So if everything's good, it should be nice and snug in there and flat. Now, your light here is going to slide down into this diffuser. Once again, with your light heading out this way. So this would be the back side of your circuit board where the wires get soldered. Just want to make sure and line up your wires, one set on top of the other, and then slide that board into the slot. Make sure it's all the way so that your LED is nice and square in there. Okay. We've got that. We've got our diffuser piece put together. Now we take our diffuser piece and put it down in here, and we need to keep an eye on how that diffuser goes in there. In the more rounded corner, I don't know if you guys can tell the shape there. This is the more rounded corner. So this is the corner that's towards me. So the two chamfered corners are the part that go in towards the top fan when you place this in there. So you'll place this in there, fiddle and fight with it, because you put it in there at an angle instead of straight. Get that in there, get it lined up, and push it down. I tend to wind up using a driver to get in there and kind of push it down where I can get a couple of parts of the edge at the same time. Did pop down in there. Mine, for whatever reason, appears to be kind of tight. There we go. You want to get it pushed down in there like that. This piece right down there. And then this piece, of course, if you look at the opening, you can see where you've got kind of the slant edge over here on the right-hand side. That tells you how your piece is going to be going in. So this edge goes in first, and this becomes the clamp that locks it in place. So you just need to fiddle with your wires to rotate this around in the right way. And then it just becomes a press fit. And I've seen some people where it just like barely pops in real easily. I always need to provide a little bit of ugga-duggas, but you want to make sure that it's fully seated in there. And then if you ever need to, you can see going through the fan housing that you can get to that clip and try and squeeze it together to pull that back out, because that is a locking clip on this side right here where my finger's at. So you should be able to pull it back out at some point. Now, your wire with the connector end gets routed up through this S channel, and then this extra wire we just need to fold out of the way. So in the S channel, and then under our clip there, and that brings our wire up. And then, like I said, the rest of this wire is just going to get pushed down in that little hollow, and our fan will lock that in place underneath there. So we do have a couple of extra pieces. We'll tag them over here with our Xers. Welcome in, Otter's Danger Den. Hey, Timor. Welcome in, everybody. So the diffuser's inserted. Our wires are properly cable managed now. Next up, there's a support structure. This is designed to break during the fan installation. So that's the little support, the little support piece right here is holding this round compression piece. And there's the same thing down here on the bottom. It's just like one line. So when we go in there, those pieces will snap. Don't worry about it. It's not coming out. It's just going to make sure that it gets a nice um, compression fit on those fans. Yep, time check. It is noon. I've got 2 hours. Like I said, Mod Light, I do have two different alarms. One is my home assistant, and the other one is the on my phone. So I've got two different alarms set. So I should be good. Give me 1 second to dig down here for the fans. And obviously not in that box. Let me grab a set of fans real fast. Hmm, Here's a 5010. And where's my, we'll call that what it really is. It's 5015. And now I need a 4010. Apparently my only 4010s are honey badgers. We're going to be using some honey badger fans in here. Um, our bottom 4010. Now our honey badger fans have 3 wires. We're only going to be using 2. We won't be using the third wire in this situation. So we will cut that off and just leave it out of the way. But once again, your fan orientation, your the side without a label faces in, which means the other side is the side that's coming up and where your wires are routing. So you do want to pull your wires out of the little clips so that you have access to those wires. They're going to come out the left side here. Make sure and push these down. Take your fan, put it in, push it all the way down, and you notice how those wires are still going to hit on the clamp there. So we need to remove them from this clamp as well, just to make sure that we don't damage anything. Be careful when you're digging them out of the clamp so you don't pull them out of the fan itself. So we've got our wires out. press that top in. Make sure these wires are out of the way when you do. And then just push the bottom down and lever it in. And like I said, it will compression fit. And you may hear some plastic break. That's literally the support pieces on either side on these two pieces that we just pushed out and broke. And now we'll take these wires and route them up the same way as the other wires to bring them up to the top. And once again, I'm pretty sure our fan is either a 2-pin or a 4-pin. We're not going to be able to use this third pin, so I'm going to just bring that cable back down and snip it. We won't be using it in this instance, in this application. Hey, Royal Nomi. Welcome on in. So, yellow wire snipped. Other wires will be routed up to the top. Just pull it out of the way. The next fan gets a little bit more interesting because we have to disassemble it. So we're going to take the top off the squirrel cage here. One of the easier ways, because you're going to have to trim these flush anyhow, is just going to be to cut these edge connectors off. I always get my flush cutters on there, put your finger over the top of it, so when you cut it, that piece does not go flying somewhere and get in somebody's eye or wind up somewhere never to be seen again. There's one there and there's one over here as well. Same type of thing. Just cover it with your finger as you're cutting it. Don't cut your finger. And one on this side. So there's 3 total clips. Cut said clips. And the top comes right off and you're left with your cage. You can throw this away. You're not going to use it. If you want to recycle your plastic, then by all means. We'll want to file these clip edges down to make sure that they're nice and flat with the edge. And then we need to take these ears off. And the easiest way I've found to take the ears off is, once again, use my snips. And I try and just get in one side in the hole, the other side as close to the case as I can. Put your thumb over the edge so it doesn't go flying out and hit you in the eye. And then cut through it. Same thing in the other direction. And the bulk of that earpiece comes out. Now we can just kind of whittle away at this, and then we'll have to do some filing because you need that smooth round edge off. Just once again, as you're cutting this stuff, be careful, go slow, and just kind of whittle it away a little by little. Biggest thing is just trying to get this trimmed down as much as you can so you're not having to file it forever and a day to try and get it flush so that you can get it in the housing. There are printed parts that you can use for this. I've never printed them and used them. It was just always easier to do it this way for me. The other thing is, be careful of this fan. Do not be providing side loads to it, or you'll mess it up. Well, that's not good, Mod Light. You know, wear safety goggles, or in my case, I've got, whoops, that went further than I've got glasses. So just make sure, and that's why I always use, you know, I always have a finger over the top of it. So if a part flips out, it's not coming towards me or my face. So always be cognizant of that. And Royal Nomi, how are you feeling today? Hopefully you're feeling good, starting to get back into some sense of normalcy. Trying to do this over this paper towel so I can clean it up easier later on. Like I said, just go slow, take your time, whittle it away. Yeah, be careful. You only have one set of Mark 1 eyeballs. And believe me, I've checked. The X-ray vision and laser vision is expensive and not covered by insurance. Okay. Those are done. I'm going to just trim up these little tabs some. Okay. Now I'm just going to have to take the time to file these edges down. I'm going to use my bigger, more aggressive file, and be careful of your wires. So hold them out of the way, put a thumb in the way or something as you file this. It doesn't have to be 100% smooth and rounded, but the closer you get, the easier your fitment's going to be, especially if you have tight tolerances on your parts. Hey, Retro Maker, how are you? we are just working on filing a fan shroud here so that we can, we're going to build our Stealthburner tool head. All right, so that side's pretty close. Now we need to do the other side. If you had like a Dremel with a drum sander, that might work out pretty well as well. Just make sure to have your fan shroud somewhat clamped down, or be careful, have a good hold on it. Hey, Luke's Player 1912, welcome on in. Lucas Player. All right, we're pretty close there with our profile now. So what we'll be able to do now is do a test fitting. And you can see the orientation. Your fan is going to be kind of kicked over here to this side, and that's where you're going to be shooting straight down the stuff there. So the way I normally do it is, because this is your compression fitting, basically, I always kind of start there with the get my nozzle set, or the output set right, and then push towards that lever. You'll hear the support material break, and then you're just trying to get it down in there. And if it doesn't go, no big deal. Pop it back out, and I need to do a little more sanding right here. I can do it that way, do this way. Okay. Once again, we're going to fit that in, get our mouth going there, push that piece over, and this should pop in, providing everything is good. All right, Honey Badger, what's going on? Kind of feeling like my Honey Badger. Oh, there we go. Boom. Took a little bit. That fan housing popped in. And still going there. Nothing's rubbing. So fans in. Now it talks about putting 2 screws in. And those 2 screws would be to lock in the fan so it can't pop out. We're not going to do that because we've got our tool head board. And our tool head board that we're using is actually a 2-piece tool head board. Let me clean this stuff up real fast. So it's a 2-piece tool head board that we're using. So we need to make sure that we get that fitted in there. So as you can see, you've got one side that's got a connector. Then we've got plenty of little DuPont connectors here. That's how everything's going to line up and go in. And your connector needs to be on this side. So your tool head board is going to sit in there just like that. The screw holes will line up, and then we'll go ahead and we'll put in our 2 screws. Those are going to be M3x6s, and one of these will probably have those in there because it should be M3x6 flathead cap screw. The eyes are doing good, Royal Nomi. The eyes are doing good. I've liked that they started doing this where they've got the pens in there, but they started putting all the hardware in a little baggie, because at first they didn't do that, and it made it such a pain in the butt to dig through all the, get this stuff out of all the pins. And not seeing small screws there. So do we have them? Yeah, we've got some M3x6 flathead screws here, so we'll just use these. Yep, the eyeballs are doing good. Basically, we're doing good. We're healing up good. And apparently the flatheads don't get really down in there, so we are going to switch over and use button heads. We are going into printed parts. So we grab a couple M3x6 flatheads or button heads. There we go, that's better. So with the flatheads, it takes into account the actual head surface. So it's not 6 millimeters of thread, it's 6 millimeters from the top of the screw down through the thread. Once again, you're putting this into plastic, so just get them snug. Don't really ugga-dugga them down. And then what we'll have to do is we'll look at the SB2209 diagram to figure out which fan goes where. So this would be a CAN bus. These would be our fans. And then the 3 RGB are on the left. And then you have a spot for a 4-pin fan. So these will be our 2 tool head fans. We just need to figure out the right order. And of course, we're going to have to repin all of these over to DuPont's to get those in there. So this purple, this is the Galaxy Purple ABS by Polymaker. So it's kind of hard to see. It doesn't show up on the screen, but there it is. You can see that it's got some of the sparkle in it. This is the Galaxy Purple. Okay, so we're going to need to do some cutting and crimping. And then we can mount that on the X carriage. I need to know which fan goes where on here. I know where my RGB goes, but I need to know which fan goes where so I know how to kind of route my wires around and which side to plug in. Technically, it doesn't matter because you can assign whichever one you want, but it's easier if you do them kind of the same way and consistently so that they're always in the same anticipated position. So we're going to put those pins back there because we're not going to need them right yet. We will need our DuPont pins. This, not that, my others. Strippers, crimpers, all kinds of things. And I'm going to take a seat while we work on these. Yeah, just because. I don't know. I think I will keep this open belt. I might use it for something down the way. Or at least keep it for now because I'll tell myself I'll use it down the way. Oh, look, I put honey badgers in there, but I had Winsons. You got lucky there, Chewy. I didn't realize I had Winsons over there. Otherwise, you would have had all Winsons. You got honey badgers instead. You got the good stuff. Okay, we're going to have a seat here so I can work on this. We're going to do some DuPonts. Let me pull up Big 3 Tech GitHub. Anyone of them just get there? Eyes doing good. The eyes are doing good. Yeah. They're healing up nicely. My vision's good. I'm going to need to go in and be reevaluated in a couple of weeks. Actually, I've got an appointment Wednesday morning to revalidate, or not revalidate, but like another follow-up to make sure that the eyes are tracking well. And then probably after the next, January, after the turn of the year, we'll start looking at whether or not I need a different prescription for my glasses. And quite possibly, I may just go down to being readers. We'll see. Yep, Chewy score. Yes, scored. So what I'm doing right now is I'm over here looking for. We're looking at Big Tree Tech's website. Because what I need is the pinout of the board. Right. So we've got the SB2209 hardware. What's in the manual? Oh, that's useful. Good guide. That may be helpful. You're moving pallets till you fall over today. Are you working, Chewy? Are you listening from work? Are you being a bad employee and listening to podcasts and Twitch while you're at work? Yeah, it is a nice color. I was when I got the printed parts from the Rocky Mountain Rep Rat Fest when I won the printed parts kit for the 2.4, which turned into Fey Dragon. It was pink and purple. It was the Galaxy Purple from Polymaker and Sparta 3D. Um, was it Sparkle Fluorescent Pink or one of their Sparkle Pinks? So that's the first time I've dealt with purple and pink, and I was like, this is a beautiful Galaxy Purple. It is beautiful. There we go. That's what I need. So we have the RGB pinout here. So it's ground, signal, 5 volt, which is good because our wire is black for ground, red for 5 volt, blue for signal. So that's good. We just need to be able to bring it up and plug it in here. So we really don't need a whole bunch of wire. But we'll probably do something along the lines of that just to give us the ability to push the wire around some. You can, you know, you don't have to, don't be stingy and crimp your wires real short. That just bites you in the butt more later on. And then our fan wires here, that's the one I need to know which fan is which. So we will figure that out real quick here after I get some swapped around in order. Mhm. Fan one, fan two. Wow, that's telling. So is what I guess what I'm trying to figure out is fan one the hot end fan or the part cooling fan? Voltages appropriately. Okay, there we go. So the turbine fan is the top one, which winds up being fan 2. So fan 1 is hot end, fan 2 is part cooling. So we need to remember that. And oh, there we go. So their silk screening is great, but the plus and minuses are underneath the pins. Like, gee, guys, that's a pain in the butt. So we'll do something along the lines of that, and we'll do a plus and minus. So it'd be good to cut about here. And I don't know about you guys, but I always use side cutters to cut my wires. The the wire cutters that are part of these strippers, like on these particular ones, suck, and most of the time it just bends it over. Kind of annoying. Okay, so we got those cut. We will strip a tiny bit of it. Then need to have a whole lot stripped off the ends, just a little bit. And we're going to be doing DuPont connectors, which are DuPont connectors. So I do mine a little weird. We'll start off there. So for the part that goes over the wire, I still tend to use what are these? These are the iWis, which is now, was it Crimp It or Crimp On? This is the IWS 2820M. I'll still use this for the part that clamps on the bare wire. You do not want to use these to try and do the teeth that goes over the insulation because they're made to round over instead of curl in. So on your standard JST, what that iWis tool is doing is curling it in like this, right? On the DuPont, you want it to curl around and make a circular oval around the wire. So I still use my iWis, for better or for worse, to get it cramped onto the wire portion. And then for the other portion, I'll come back and use something designed for DuPont. And simply just because I've found I've had better luck and crimps doing it this way. And it helps to get your finger out of the end of the crimp, and it'll actually crimp then. Or not. Screwed that one up. So technically you would do, you do one of these, and it would um yeah, so you've got one part that would do the main piece, and then a different part that would do over the wire. We'll give it a shot. Yep. That's why I don't like trying to do those. This never seems to work out well for me. Go back to this. That part there. That part does the round over on the insulation. Everything looks nice. We'll be good to go. Luckily, they give me extra pins, and if not, I've got extra pins. Yeah, the Galaxy Purple really is pretty cool. It is really cool. I'll give you that. And I also know people that are really fond of soldering their connectors versus doing the crimps. I always do crimps. Okay. Now, with the connector side of it, um, I tend to try and go one way or the other. Either all of them, the locking tabs are facing up, or all of them, the locking tabs are facing down. That way I always know which way they're going in. It's kind of the safer bet that way. In this case, we're going to do it with the locking tabs facing up, which means it's going to go in that way, and my positive is going to be on the left side. And yeah. One, second one. In. Yay! So nice DuPont connector. Now we're just going to spin this around and bring our connector in, slide it on the pins, and we just want to kind of press fit it down there to make sure it's down and out of the way. Now we also need to do this fan, which I'm going to try and bring this up around same direction and just do right next to it. And I should be able to just basically trim these off and do DuPonts on them. I've also brought it around and kind of brought it up this way in the past. It might actually not be bad either. Now we'll do it that way. We'll do it that way. Trim these wires about there. So same type of deal. Peel off about 2 to 3 millimeters of insulation. You don't need any more than that for these connectors. I know crimping is not all that fun, and I probably should have worn my crimping ain't easy shirt, but I forgot we were going to be crimping on the connectors here. And so again, using my standard I-Wist that I would use for JSTs to crimp onto the wire, the exposed wire, and then the standard DuPont for the back half. Make sure that we get a good connection and crimp. Okay. We'll grab our connector, and once again, since we're doing it locking side up in the same polarity direction, our positive is going to be on the left. Just slide that in. If that locking tab is down so that it sticks. Same thing on the negative side, the ground side. Do a little pull test, make sure it's good, and then we're just going to wrap our wire around once we plug that in. Just want to keep our wiring nice and clean and as low profile as possible because that keeps it out of the way when we plug everything in. Hey Tactile, how's it going? Now we'll be able to play with our order here some, but we just need less here, so we'll put that off there. And we'll get our wires ready and then we'll worry about putting them in order. A little more of a pain in the butt to do because it's FEP wire. I just have all kinds of fun trying to get FEP, um, FEP wire stripped. There we go. All right, 3 more down. Are you taking off, Rodney? So have a great day. 3 more of our pins. I'm just trying to pre-crimp them a little bit because these are the smaller wires. I'm using the 1.0 on my crimpers, and it just helps to kind of pre-crimp it just a scooch. Doesn't have to be a lot, just a scooch. Right there. And done. Too much attention to chat while I'm trying to do this wiring. I apologize ahead of time. So how's it going, Tactile 3D Pictures? Hope everything's going well with you. Hope everybody's getting ready for a wonderful holiday season and a break to spend time with family and friends. Okay, and once again, our locking clips are facing up, and we're going to go round on the left. Then our RGB signal, which is the blue. And then our power, which is red. And all three of those are locked in. Let's bring that down and slot that in. Once again, there's our wire routing, keeping everything nice and low profile and out of the way. And once again, fan 1 is the hot end fan. Fan 2 is part cooling. So let me grab a Post-it note and pen. So fan 1, fan 2. Fan 2 is part cooling. Fan 3 is, or fan 1 is hot end. Awesome. Okay, so that's all wired up. Installed with those M3x10 button head cap screws. We got M3x6. It's in there good. Not going to go anywhere. Now on the SB2209, we do need to set the voltage of the power supply, or excuse me, the power supply, for the fans on these little jumpers right here. Tiny, tiny little jumpers. Gonna test my eyesight out again. So these are 24-volt fans. So I need to use these tiny flipping jumpers. And they go on the left towards the connector. Fan 1 is the bottom. Fan 2, the hot end, is going to be the next one up. So the third one would be for a PWM fan, which we're not using, so I'm going to leave that one off. We've got our RGB connected. Okay. We're using a standard thermistor, so we don't need to change anything on our thermistor pins. Okay. And once again, in order to install this, we kind of need to have the tool head portion in place on the machine, simply because the standoffs and the thermistor input. So we have to basically be able to have the tool head mounted in order to add the board in and then start wiring things up. Now we're probably going to have to do some more wiring. In fact, where's our end stop? You guys read that? Because I can end stop. End stop. So the end stop is the top left pin here, which is a 3-pin connector. So we'll need to get that wire created and configured, and then we'll have our probe. Now the probe for the CAN bus. Oh my goodness! Look at that. Love it. So this is the side that goes into the probe. It's standard JST. They've got it already pinned out to go to this board. We're going to assume that their pinouts are correct. If he's printed in a position that I can't make sure that the wires are the same. So we're going to assume that the probe is correct. And the way this will go is in stop is the top left, probe is the bottom left. They're both 3 pins. So we still will need to do the one for the end stop. And since the end stop is going to be, we're going to need to solder on to the end stop, the wires. Life gets a little bit easier, and I did that to myself again. I need one of those little 2-pin connectors. I mean, me, I'm just putting all the screws and little tiny itty bitty jumper cables back in there. Okay, that's there. We're done with the pins that I just dropped on the ground. We're going to put these back in here. So what we're going to do for our end stop, we need 2 pins. We need them to be able to go into those little tiny things. And this should be enough cable to do the end stop. So we will grab a white and black cable. Doesn't really matter. We can grab from the other side. Doesn't matter which way we go. Gently peel them off. And once again, one end has these connectors pre-crimped on there. And you can see just how fiddly those would be and why I am so glad they included these. So there's a new version of the SB2209. So this one comes with a STEM 32 processor and a 2209 for the stepper driver. 2209's over here, STEM 32's right here. There's a new version of this that's based on a Raspberry Pi 2040. And that allowed them to go with standard JST connectors that everybody's able to actually crimp. And that works well, except you lose things like your ADXL, the no input shaping with the 2040 board. There's a few other things feature-wise that dropped off the board to enable them to use the larger connectors, and they switched over to the RP 2040 because it was cheaper to use, and sorry, it was cheaper for them to use the RP 2040, and it worked out well with packaging. So I grabbed the 2-pin connector and I actually needed the 3-pin connector. Just I'm going to use 2 wires of said connector. I get to dig this back out after I took so long to fiddle with it, getting it in there. And let's see if I can just reach in there and pluck it out without popping a lot of, there we go. And I'm going to go ahead and grab, I believe these are M3x10s. Mount this on the board. What? There we go. Really, it wants us to use M3x10 button head cap screws. Just make sure what these are. And these are M3x10. I'll go ahead and pluck the other two M3x10s out of here. Hopefully. I do like they give you plenty of connectors and stuff. It's just like I said, these connectors are so small and fiddly. It's like a migraine waiting to happen. Okay, so we have our two wires here, and on our end stop, we're not going to use power. We're just using ground and signal, and that's going to be we'll say the right and the center, and we won't use the one on the left. I need to figure out which way this goes on there. Goes in like that. And you really, really, really want to make sure that you're shoving these pins in there right, because you're not getting it back out very easily. There we've got the cable that will work for our in stop. And what we'll do is we'll just go ahead and solder these onto the end stop. And this should be plenty enough cable to route it up from the back up into the tool and up there. That'll be for our sensor. We won't need this anymore. We won't need this anymore. All right, and I think we're ready to clear some of this crud off the table. So let me put this up. Clean up the table a little bit. We'll bring the printer back up here and we'll start actually putting stuff on the printer. Yep, Chewy's finally going to get his Voron in about 6 weeks. I don't know. Go ahead and pop these back out and use the M3x10s that they told us to use. Plus now it's a digital dragon build. Get this up, I'm going to have to start figuring out how much my time's worth so that we can just start doing printer builds for everybody else. I don't think Miss Dragon would mind me doing printer builds as long as they're not staying here at the house, because not too much more places in the house I can throw printers. Apparently, she doesn't like them being on the kitchen table. Okay, so we've got these pieces. Let me see if I can't put stuff in a way that um, I can get the printer back up here without potentially damaging anything. There we go. Printer on table. I'm going to go ahead and grab my tool head and just bring it a little bit closer. And we'll go back over to our other document, which is the assembly manual for our Stealthburner. Talks about the two M3 by 12 screws. Those are those two screws that we installed up here at the top. Hey, Jose, how's it going? And those screws are kind of loose. I'm going to go ahead and put some Loctite on these screws here because they're just kind of loose in there. I do want to make sure that they can actually stay in there and not be too problematic when we're trying to. So these screws here are locator pins. Okay, they are not um, holding that lower piece in. They're simply there to locate the tool head. The screws that go all the way through are the ones that will actually hold the tool head in place. I'm just going to put a little bit of thread locker compound on these. And those little M3 by 6s that we had, I'm going to go ahead and put down here at the bottom. Once again, these are the pins that are going to hold the bottom of the tool head cartridge and just kind of keep it in place. Once again, just a tad bit of thread locker. And they're going in the bottommost holes and they go all the way in. Hey, Jose, how's it going? How is it going? Long time no see. Normally see you over in Modbot's channel. Okay, so those are in. Now our CW2, once again, we've kind of got things pretty well together. We're going to do some more wiring on this on the printer. Is going to come and let me see if I can't flip this around. I'll make it a little bit harder on me, but all right. So here's our carriage. We're going to take our CW2 and the notch sits right down here in the notch of the print tab there, or the print tab of the CNC tab. So it just sits right down there. We're going to do an M3 by 8 socket head cap screw on the right. And then on the left, believe it's another M3x8. Yep, on the left side. And this actually goes through this hole right here. Should be able to get the head through it, I hope. Yes. And that'll screw in right there. Those two pieces are nice and tight now. Next up, we're going to take our tool head. And once again, the two tabs here on the tool head go right up underneath those two screws that we just put in place. You need to make sure that your wires are kind of out of the way, or not out of the way, but come up through the channel behind here. We'll bring our wires behind the channel there. Make sure you're getting your get your bud tube lined up there. And if your two screws are in there too tight, let's go ahead and unscrew them some. So I said these are locator tabs, not tighten down tabs. Because if you tighten down on there, it will it'll push the bottom out is what happens. Does not feel like it is aligning for me. Okay, so for giggles, let me get that out. But I think we might have just a tad too much on our Bowden tube. So we might have to very gently and very lightly, like shave off a tad bit of our Bowden tube. Because we're in there, but our bottoms aren't sitting up on the button head cap screws. I think we need to shave ever so slightly, a little bit off the top of our Bowden tube. Not a whole heck of a lot, just barely. This is just fiddly fitment stuff that you want to make sure it's nice and right, because if this fits right, then everything is right as rain. You know, I wonder. I wonder. I wonder if we're having issues. Oh, well, we got an ad break going on. I'm wondering if we might not be having issues with the um, Bowden tube channel from the bottom of the CW2. Like we didn't clear that hole out some with the reamer. So it could just be very well that that just needs to be pulled a bit. Or not pulled a bit, but opened up a bit. And because this is built and it's, I'm going to call it a sensitive tolerance component at the moment, I'm going to do this by hand and not use the drill, just so there's no chance of jacking it up. And we can try the fitment here as well and just make sure that it fits. And I'm still getting, I'll say, a little bit of push, like I'm squishing the PTFE tube. So let me shave off just a section of PTFE. Hey, subsector, how are you doing? It's not going to be a lot. It's going to be very short, but I just need to take off just a sliver of the PTFE tube. Because we're getting a bit of compression going. And if we can get some of that compression out, we'll be better off. If we can cut our Bowden tube at a 90-degree angle, we'd be better off too. Fit this outside of the printer. We're getting a lot better fitment right there without any compression, so we'll be good to go. So we'll put this back on the printer. You're recovering well now. You were sick, right, subsector? Not surgery or anything that like that? Gotcha. Well, I hope you are feeling well and that you're over all of that and can have a good Christmas. Okay, so we got that fitted. We're going to lift that door. We're going to bring our cables around the back there, line up our PTFE tube. And did you see how that just barely locks on there? Um, these were just barely able to lock in over the top of these M3x6 screws, right? That's all they're there for, is to provide a little bit of ledge for this to compression fit in there. And that's why these are just locator screws for these tabs. And then it sits in and it just snaps right into place there, bada bing, bada boom, and everything's nice and lined up. So now we'd be able to put our front face on with no issues, or should be able to with no issues. However, now that we've got these pieces here, we need to add our SB2209 before we do that. So let me turn this sideways. And the reason we're doing it in this order is so once again, so that we can plug in our thermistor cable here before we go to mount it in. We're going to need our backing plate, and that's going to go in there, and it can only go one way. And provide a spacer, right? So we'll get our M3x10 screws that I set aside somewhere. We'll get these started. Hey, it might have been that I've had too much coffee, but that can't be because I still haven't finished the coffee that I made early today. So fiddly just because it's being fiddly. And where's the other one I dropped? There it is. So we're 1:30. We've got just a little bit longer before my hard stop because I do have a hard stop at 2. So hopefully we'll be able to get the board installed and partially get we'll get the tool head buttoned up, but we'll probably have to do a little bit more wiring before we're totally done. Okay. So we're going to take our thermistor wire here, tiny little 2-pin connector, and install that on the board. You say we had installed it before. So that's installed on the board now. Now we will get these wires out of the way. We'll feed the board into that slot as gently as we can. Come on, you can do it. The darn spacer that's now hitting in the way in a weird angle. Oh, I need to take the lower one out so I can rotate the spacer up some to get the spacer out of the way and through there. And let the spacer drop down in place. And your USB plug will kind of flip around in place and that'll help line things up. Okay. So now that board's on there. Once again, our end stop will go on the top. Our sensor for our tap will come around and go on the bottom. Try and just move some things around so I can get the printer closer to you all. Marcus 492, how are you? This is a 3D printer that we are building. So we've got our connector here that will fit onto our tap. So our tap sensor. Oh man, I thought we had it done the right way, but we need to go from this JST to this style JST, which is going to be a sad day because those crimps are going to suck. And I think what I did the last time was I actually cut some of the sleeving back and then soldered on their wires that are already pre-crimped rather than try and crimp my own, because crimping these tiny connectors are, I can't explain to you how much of a pain in the butt that is. So I will do that part off stream. We'll get that set up off stream. These cables here for the whatchamacallit, the hot end, they're going to come around and the connector's right back here. So they're basically going to come around and do a quick bend and connect in. So I'm going to trim these down a little bit more and fit these with a 2-pin DuPont connector, and we'll get that going. Well, I'll do those connections off stream as well, just because Well, we don't want this to be a complete connector stream, do we? Go ahead and cut this off here as well. So that's trimmed to size. Once again, we'll just bring it around, pop it into the back with a locking, microfit 3 connector is what these get. So we'll have these two to crimp and microfit. We've got our extra fiddly wire here for our thermistor. We'll have our end stop wire, which we went ahead and whoops, that's not the right one. We used their pre-crimped wires for our end stop wire. That'll go up there, come down around the back and plug into our end stop that will mount in there. So that wire is long enough to go around and do that. So that'll be our end stop wire. We'll have to do some soldering on an end stop for that. And then, yeah, the probe wire I'm going to have to figure out and redo. Other than that, we're close. We're close to being done with the motion system and the hot end. So once we get those things done, we can go ahead and put the front of our tool head in. Like I said, we did a good wiring job on this to keep all the wires nice and flush with the board and out of the way. Oh, nice, Marcus. What kind of printer are you looking at getting? And this is just going to slide onto the front, and our connectors is going to go on the connectors on our SB2209. And that's what connects everything up. And that will supply the power for our fans and for our RGB lights in this front shroud. Why is that? Okay, yeah. It was just a super tight fit. I just don't think these were tightened all the way down, and then that would be why it felt like the alignment wasn't 100% right. There we go. The other thing we need to do, and I haven't seen it yet, there should be a heat sink that'll go on that 2209. So we definitely need to get that on there because this gets hot. And if you don't have that heat sink on there, you will run into problems. Oh, there it is. And then once again, they provide you the pre-made cable that will clamp in there. And then we'll have another piece that will go over the top of this and screw down that will provide that strain relief so that that cable doesn't come out on its own. And then the other side, you've got the two twisted pair there are your can high, can low. And then here's the power that will go into 24 volt. And we'll probably have to cut this and shrink and reduce the length on this, but that's no big problem. That's easy enough to do. Okay, so here's that heat sink. We just need to peel the plastic backer off the adhesive and get that attached. And probably a lot easier to do when you didn't just cut your fingernails. Of course, it's probably been easier to install before putting the board on there. The Ender 3 V3 SE. Okay, that's one of the new ones that just came out, if I remember right. So that's really cool. That'll be really neat. Wire, in-stop wire. This is an extra wire. Thermistor. I'll set thermistor back in the bag because we're not going to use it. We were using theirs because I don't want to crimp cables if I don't have to. Okay. So I'm just going to try and clean up a tad bit and we'll chat for a little bit because I do have, like I said, a hard stop right at 2. But let's see, we've got everything pretty much installed that we could install on the tool head today. I'll work on crimping these microfit connectors and we'll be able to plug that in. Our front fan shroud should now line up a little bit better. And plug in. And we'll add our screws. So we got M3 by 25s at the top and M3 by 50s at the bottom. Cool, none of which are in the kit. I think, nope, there's M3 by 50 and 30. Right, 2 M3 by 50s, 2 M3 by 25s. So we'll get these installed. Now I find it easier to get these lined up and not screw them all 4 in it. Don't screw one in at any given time. You need to kind of get them all going at the same time. Otherwise, you could run into some issues with alignment. Just kind of get them all started and then screw them down a little bit at a time. So the 2 bottom screws are going all the way through the printed parts, all the way through the tool head parts, and they go into the bottom of the CHC or CNC tap. So you should feel those lining up. And then your other two are just going into the CW2, which is already mounted to the CNC tap. So everything should just be snugging down. Uh-oh, started gambling again. Yeah, I think the V3 SE would be a good one over the Neo. Yeah, exactly. Exactly. So this is our full up tool head as it stands right now. Like I said, we still have a few things to, wire up. We'll need to definitely cut our motor wire, re-terminate that, and it plugs in right here from the back. We'll get our heater wire ready to go, and we're going to leave it loose for now. We're not going to plug it in, and there's a reason for that. Because we still need to program our CAN bus board. And there was some issues initially when putting these in DFU mode. So they always say do not have any heating sources plugged in. This one should be of the newer batch and shouldn't have that issue. However, safety always. So when we go to put this in DFU mode, which will be pressing the two buttons and then releasing them in a certain sequence to get it into DFU mode so that we can flash the CAN bus board. Then afterwards, we'll plug in our heater. But we can have the end stop, we can have the tap probe, the motors and everything else installed. It's just for the heater pin on initial boards was actually plumbed to the same board or the same pin that's used for DFU mode. So every time you would go into DFU mode, if you had 24 volt coming up to it, it would immediately start heating the heating elements. But once again, we've got 10 minutes before my hard stop. And it's a hard stop because I have to go drive somewhere for a meeting or an appointment. So let's try and figure out whom we might want to raid out to. And Marcus, just to let you know, I do stream Tuesdays and Thursday nights at 5:30 p.m. Eastern Time, and Saturdays we start at 10. And Saturdays are normally the days I wind up running way, way long. But today we're having to cut it short just because of a prior engagement that I've got. And I'll just screw shut. And normally you would have two tones, so your fan shroud would be a different color than your main body back here. Chewy wanted everything on the gantry to be purple, so that's what he's got. Is everything's purple. Um, so yeah, tool head is now functionally installed. We'll need to finish some of the wiring. We'll need to go ahead and trim our excess belts off on each side so that we get full range of motion. Yeah, let's trim that off, and then we'll tension everything up. And then, yeah, we're done with that part. We come back to the main part of the assembly manual. We're not doing the afterburner, so I'm going to dust scroll through this. But I think the next step up is going to be the electrical and wiring. Yeah. So we'll be getting into the electronics next week. Yeah, auto bed leveling is very nice. You still want to get your, oh, we got an ad break. I'll wait until after the ad break. Oh, yeah. I can't tell you how much I am happy with the movement on this. Moves so much easier than mine. Um, we will need to wire up some end stops. Um, so the X end stop's going to mount back here behind the tool head on this little pod here, and then the Y end stop is going to mount back here, and we'll have another piece, and it goes right into these front two motor mounts. We'll replace those. The Y end stop will be right there. This is the little kick butt that'll hit the Y end stop, and that's where we will set that up. And then our umbilical cables, we can bring right down the channel here and then up through our Z-axis drag chain. Or what I've done in one of mine is I've run it through the back panel. So Chewy, if you have a choice, let me know. If not, I think off stream, I'm going to solder the XN stop together, and I'll work on getting this plumbed over to another, whatever the hell this pin connector is that we use on here. So, yep, timer went off. It's 1:54 by my calculation and my watch. So, yep, we're pretty good. Like I said, I've got my phone and my home device that should be bringing here shortly. I'm going to put these two down there. I'm going to take and put this on the ground. And I will I will work on getting the end stop wired up, ready to go. This, the tip cut off of this and wired up with the other connector, ready to go. And the motor wire cut shorter and recrimped, and the micro fit for the hot end crimped and fit. So we'll have all those done and ready to just plug in next stream. And then we'll work on installing the electronics underneath the printer. So with that, we need to figure out a good RAID option for today. So kind of one of our normals is the Free Heathen. We like going over to him because he's always streaming right at this time frame. So, but let me see who else is online. You've got yeah, the Free Heathen. Juana, who's playing American Truck Sim. Painterly Git, who's painting some miniatures. Foxen, who's playing games. And that's pretty much it. Oh, hey, Pezliz. Now you're throwing out all these new names of people I don't know. So you've got Fabulous, a tall Canadian, Sin Shop. Don't know them. I do not know them. All Canadian. All Canadians doing stuff on the lathe. I don't know what. And then Fin Shop. Oh, Sin Shop is looks like they're checking out some BattleBot stuff. That's kind of cool. You've been here just trying to get ready for your party? Okay. Okay, so yeah, let's I kind of like the BattleBot thing. So let's raid over to Send Shop. Especially since, believe it or not, I can't remember Rocky Mountain, but I know Murph and Earth, which is now 3D Printopia, they had the ant weight battle bots, the little small guys like about like that. So we want to try and figure those out because we may, there's a bunch of us that may be bringing some of those to the shows this year, being FY24. So we're going to go ahead and get the raid started for Send Shop. Please come on and join me over there for the raid. Like I said, unfortunately, I'm going to have to raid and run. Thanks everybody for being here. I really appreciate everybody coming in and hanging out with me as we do these builds. It helps keep me on track, and you guys provide me some good company while we do this. So thanks a lot, everybody. Like I said, I'll see you all on Tuesday as we head back over to the Annex K3 build. And we'll do that Tuesday and Thursday, and then we'll be back here on Saturday for the 2.4 build. Thanks, everybody. Have a good one. See you later.